Welcome to Algebra 2. This is our first lesson for Chapter 1, Section 1. We use the Big Ideas Math textbook, and we're going to be talking about the characteristics of parent functions. When you think of a parent function, you want to think about your parents. You come from them, and that is how our graphs are going to work. A parent function is a function expressed in the terms of the simplest variable. Okay, so what you want to think of then is like, if you've got y equals x squared, some of you may remember that that's just a quadratic or a parabola. It's opening upward. It's based at the origin. Now, I can move it and do all sorts of things with it. I could say it's like 2x squared minus 3x plus 3. Now, that's a more complex function. It's not going to be at the origin, but its parent, where it comes from, is the x squared function. Now, a transformation is the change in shape, size, position, or the orientation of the graph. And basically, anything you do to the parent function is going to transform that graph. And it could shift the graph using a translation. And we can shift a graph vertically or horizontally. And we're not going to change the shape, the size, or the orientation of the graph. We're just going to basically move it. And a reflection also doesn't change the graph in any way other than just flipping across a reflection line. So translations and reflections are isometric, but a vertical stretch and a vertical shrink, they are going to change the shape of the graph. For instance, when the parent function variable is multiplied by an a value greater than 1, so let's pretend it's 2x squared here. You've got your parent function, x squared, and your 2x squared is going to be a narrower graph. What you want to think of is that it gets taller, faster. Now, a vertical shrink, be careful here. Look at this a value. It is when the a value is sandwiched between 0 and 1. So you're thinking proper fractions or decimals. So I'm going to change my pen color real quick to x squared is my parent function. Let's say I put a 1/2 in front of it. Now all of a sudden that graph is wider. And it is just basically not taller, faster. It's the opposite. It is shorter, or it grows slower. Okay, moving on. We just want to be able to identify a graph quickly by its picture. So when you see a V-shaped graph, you want to be thinking of an absolute value. Which would be the absolute value of x. Now, if you see a graph like this, where it starts at the origin and it goes off, you should be thinking square root, and we'll talk about why. If I put a 1 underneath a square root, I know that the square root of 1 is just 1. If I put a 0 under the square root, that's okay, I know that that's 0. But if I put a -1 under the square root, it's actually undefined. You're not allowed to do that. And that's why when you look over here, there's no graph over here. Okay, over here, this is a line, but more than being a line, it's also considered a constant function, because no matter where the x is, where's the y? The y is actually always at +1, and so this is called a constant function because that y value is never changing. Okay, over here when you see something like this, you're going to be thinking of exponential. That's where it starts really close to this asymptote, it's never actually going to cross into the negatives, and then it just shoots up, shoots toward the sky. It gets exponentially bigger. It grows quickly. All right, for our second page here, let's go with what we know right away. Here's linear function. It's a line. You want to be thinking y equals mx plus b. And here's a quadratic. So you're thinking x squared. Now, these other two you might not recognize. You might not have ever seen them before. This one here is a cubic. So you're thinking x cubed. And this is reciprocal. So you're thinking 1 over x. Okay, moving on. Identify the function family to which f belongs. Compare the graph of f to the graph of the parent function. Well, what you might not know is what the graph of the absolute value of x looks like. But it's a v-shaped graph, so I know its absolute value. I'm going to go ahead and give you a little hint here, let you in on a secret. You draw it as if it's a line with a slope of 1, because there's an invisible 1 right here. And then you just mirror the image. Now, if ever there's something you don't know how to graph, you can always make a chart. So let's plug in -1, 0, and 1. If I plug a -1 into the absolute value of x, I get a positive 1. If I plug a 0 in for absolute value, I get 0. When I plug a 1 in, I get 1. That's because absolute value is a measure of distance. So real quick, if you're not familiar with absolute value, think of yourself, your person, standing in space. Right now, this person is standing at the 5. Okay, then I'm going to get my little green person over here, standing at -5. The question is, how far apart are they? Well, if you look here, they're 10 units apart. Distance is never negative. Even if you dig a hole in the ground, if I say, hey, how deep is that hole in the ground? You're not going to say, oh, it's -5 feet in the ground. You're just going to say, oh, it's a 5-foot hole. Okay, so that's how we want to think of absolute value. It's always positive because it's a distance. Now, let's actually get back to our parent functions here and compare the graph. What you want to notice is that this blue graph of 2 times the absolute value of x plus 1 has been shifted. It has been shifted up to +1. And the other thing you want to notice is, remember I told you want to think of slope of 1, so I had this over here, purple slope of 1. Well, look at your slope here. Your slope is actually a slope of 2. That's coming from there right there. Now, it's not actually slope, but you can think of it as slope. And you can graph it that way too. And then just reflect it to the other side. Like so. So, what do we know about this graph? It has a shift up 1 unit compared to its parent function. And it also has a stretch of 2. Okay, moving on. It's a U-shaped graph, so right off the bat, I'm thinking that this is a quadratic function. And I know that that would be x squared as the parent. If you don't remember how to graph the parent function, then you just need to make yourself a quick little table. Now, if you take -1 and you square it, what you really have is -1 times -1. Hey, that's 1. 0 squared is 0, and 1 squared is 1. So the parent function starts at 0, 0, goes this way. Now let's go ahead and put a 2 in here. 2 squared is 4. And -2, I could do it, but I also know it's going to reflect. It's going to be +4. Okay. Here's our parent function. So what has happened here? We have a shift. Three units right. And we have a shrink. It is getting wider, slower than the parent function. The shrink is of 1/4. Okay, what you want to notice here is that 1/4 is out front. The x minus 3 is in parentheses. And it says x minus 3, but the shift was 3 units to the right. Okay, keep that in mind. Let's move on. Here are our shifting guidelines. Additions and subtractions outside of parentheses move the parent function up or down depending on sign. Okay, I'm going to give you a quadratic parent function. I have y equals a times the quantity of x minus h squared plus k. When they're talking about additions and subtractions outside, moving up or down, they're talking about the k value. When they're talking about additions and subtractions inside, moving the function right or left, they're talking about the h value, but it is the opposite direction of the sign. Now, multiplications are the a value, and remember, it's a stretch or a shrink depending on that a value. So stretches are a values that are greater than 1, and shrinks are a values that are sandwiched between 0 and 1. Multiplication by a negative flips the graph over. So now instead of opening up, maybe the graph would be opening down. Moving on, we're going to go ahead and describe the transformation. Okay, so we're using function notation here. So I will too. Let's just call h of x. I did make that up. I could have called it anything I wanted, but I called it h for fun. And it would be x. Whoops. Let me grab my eraser real quick. I'm making a mess down here. Okay, so there are no parentheses here. This addition has happened out, which means I would shift up 3. This one's already called h of x, so I'm going to go ahead and say g of x is x squared. Now, this minus 2 is happening on the inside. Do you remember what happens? If it's on the inside, you do the opposite of what you see. So because I see a 2, a -2, I know the answer is 2, and it's right. 2. Now, here we have the absolute value of x, and we have so many things going on. First of all, this negative gives us a reflection. This minus 9's on the inside, so that actually means we move to the right 9. And this plus 11 is on the outside, so that means we're going to move up 11. Okay, good luck with your practice work. Let me know if you need any help.